friends, here in this video we will see the construction and description of differential YouTube manometer. For that we have a diagram here. As we can see here, we have figure number A, in which the two pipes are at different levels. In figure B, pipes A and B are at the same level. Now differential manometer is used in a pipeline to measure difference of pressure between fluids in two pipelines. Like we can see in the first figure, here we have A, this is pipeline A, this pipeline is B. Now both the pipelines, they can contain different liquids, and when we want to measure the difference in pressure of two different liquids, we would be connecting this differential YouTube manometer to both the pipes. Now what will happen? From pipe A, the fluid will enter into the left limb. This is called as the left limb of the YouTube manometer. Similarly, from pipe B, the fluid will enter the right limb of the differential YouTube manometer. Now this black portion which we are seeing, it is mercury, or we can say heavier liquid. Now once the fluid enters left and right limb, both the fluids would be balanced, that is the height would be adjusted, where this H indicates the difference of level of mercury in both left and right limb. If we compare, this XX is taken as the level, or you can say reference. So from XX, if we see in the left limb, there is, we can say, no mercury above XX level, but in the right limb there is mercury up to height H. So the difference in level of mercury is H. Next, the distance between the level of mercury up to the center of pipe number A, it is called as X distance. Similarly, the distance between the mercury level and center of pipe B, that is denoted by Y. So these are the notations. Now we can easily calculate the pressure difference in both the pipeline by using some form of equation. Next, here in figure number 2, we have both the pipeline A and pipeline B, they are at the same level. These two pipes, they can even contain same liquid, of density would be same for both the fluids. Now in the left limb again the fluid would enter, and from the right limb also it will enter. The mercury would be balanced, and here we have H as the difference of mercury level. X is the distance, we can say, from the mercury level up to the center of pipe A and B. So once these readings, they are balanced, we can take the values and we can find the difference of pressure. So now the method is very simple. Like if we see two pipes at different levels, from that also we can calculate the pressure difference, and the equation would be in such a way that first I'll write for the left portion. For the left portion I can write this as, since here we have pressure in pipeline A, so I'll denote it as PA. Next we have this entire column of fluid which is filled. The height of this column will be X plus H. So there is pressure exerted by this column, and it would be given by hydrostatic law, that is rho G into X plus H. Here for the density I'll write down A, because the fluid is from pipeline A. Now this is regarding the left portion. In the left limb we have this much amount of pressure. For the right limb I can write this as, here we have pressure B of the pipeline which we want to measure. Next there is height H plus Y, that is pressure is exerted by mercury as well as pressure is exerted by the fluid. So first I'll consider the fluid, its height is Y, so I'll write down plus rho, that is density of fluid in pipeline B, into G into its height, that is Y, plus the density of mercury into G, that is acceleration due to gravity, and height of mercury. Now here I have written the pressure equation for left limb and right limb. After that I would be taking the difference, therefore I'll keep PA minus PB. This PB I am shifting it onto the left side. So on the right side I have rho B G into H plus the density of mercury G into H. This term I'll send it onto the right hand side, so it becomes negative, minus density in pipeline A G into X plus H. So from this equation which I have written here, we can easily calculate the pressure difference from pipeline A and pipeline B, and the same procedure we would be using for pipes at the same level. So in this video we have seen how a differential manometer looks like and what is its function and how to calculate the pressure difference.